Hi, Ismail.
Hey Albert, how's it going?
Look, I'm having a trouble with tracking this non-stationary signal. It's so volatile, and do you maybe know any model which can help me to do that?
Actually, your signal seems to be very volatile indeed. Well, I actually know a model called the hierarchical Gaussian filter. And this is a model which is a hierarchical model, and it allows you to model non-stationary signal. So here, let's assume that you have a two-layer hierarchical Gaussian filter. And then the first layer of the hierarchical Gaussian filter will model the prices that you're trying to track. And then the variance of the first layer will be governed by another time series. And that is, again, is modeled as a random walk.
I see. But how many layers I can build by extending this model?
Actually, HGF does not require you to be only specify two layers. You can specify an arbitrary number of layers. Basically, what you're going to do is that you're going to stack the random walks and you're going to couple them with the nonlinearity on the variances. For example, for an arbitrary layer I, the variance of the state is going to be determined by another time series on the layer I plus 1.
Ah, okay, I can see that. And can I run the inference in this model in real time?
Of course, we've derived the inference equations for the HGF with a framework called message passing. And in the message passing framework, you can obtain online estimates of the parameters and the states of the HGF model.
Oh, I see.
But Albert, to me, it looks like the signal you're trying to model has more than one dynamic. So it seems like the data generating process is switching its dynamics. So maybe we can do something smarter. Maybe we can introduce switching dynamics to the HGF.
Indeed.
Yeah, I think we can do that. And I think the way to do that is to introduce a hidden Markov model to the parameters of the HGF such that the the parameters are going to be assumed to be coming from a hidden Markov model. And then based on the observations, we can select which parameter is most likely to generate the data.
Okay, I see that.
Hmm. Okay, I wonder what kind of switches the model finds. Okay, here you see that on the left, the model actually thinks that there are two switches governing the prices. And actually, yeah, when it is quite jumpy, between the days 60 and 90, seems like the HGF thinks that it is coming from a different data generating process. And probably it is explaining that by the changing parameters.
I see that. But Ismail, how do we determine the number of switches?
Well, you can determine the number of switches by looking at the free energy. And you can do that by, let's say you assume that you have a 3-layer switching HGF, and then you have a 2-layer switching HGF, and you run your model, and then based on that, you are going to obtain a free energy measure. Then this free energy measure will tell you the winner, and the one with the lowest free energy is going to be the winner. Here you see that if you compare a 3-layer switching HGF and a 2-layer switching HGF, a 2-layer switching HGF wins because it produces a lower free energy. And you can do the same with the categories as well. So let's assume that you start the 2-layer HGF with 2 categories and with 3 categories. Then we see that the 3-category HGF is slightly higher, has a slightly higher free energy value compared to 2 categories. So that will mean that actually in your signal, there are 2 regimes that is governing the data generation.
I see that. Well, it would be nice to hear the extended version of your presentation. See you later.
Yeah, let's see you later at the extended presentation all day.